Good day, Upper Fives. Welcome to AP Maths. We'll be continuing with complex numbers, and more specifically, we will be doing division of complex numbers. You should have your session 8 worksheet with you, and you'll be completing that during the duration of this video. We would like to thank the 3 special guest stars who've come from their various parts of the world to help us today. First of all, to Zonke. Thank you, Zonke, for coming in. To Kristen, thank you, Kristen. And last, but by no means least, the ever capable Hannah. Right, thank you for your assistance. Righty, let us share our screen and get going with the worksheet. Right, so. There we go. Okay. So, division of complex numbers. So your first example says, right, z is equal to 3 minus 2i over 5 plus 3i in the form a plus bi, and hence determine the real part of the complex number z, the imaginary part of z, and z star, in other words, the conjugate of z. And your key idea is this. When dividing complex numbers, so I've got a complex number divided by a complex number, okay, always multiply the top and the bottom, because if you multiply the top and the bottom by the same thing, you're effectively doing nothing because you're multiplying by 1. Always multiply the numerator and the denominator by what? The complex conjugate of the denominator. So you're going to times the top and the bottom, okay, by the conjugate of the denominator, okay, because when I do that, I get rid of the imaginary part in the denominator. So you times the top and the bottom by the complex conjugate of the denominator. So in this case, I've got z is equal to 3 minus 2i over 5 plus 3i. The denominator is 5 plus 3i. The conjugate of 5 plus 3i is what, Kristen? Good, you're doing the East proud. It's 5 minus 3i. And whatever you do to the bottom, you do the same thing to the top, because then you're effectively not changing the value of anything. Okay. All you're doing is you're effectively timesing by 1, because 5 minus 3 over 5 minus 3i is 1. So it's always by the conjugate of what? Of the denominator. You times the top and the bottom by the same thing. Right, so if I multiply out now, I get z is equal to, just use FOIL, 3 times 5, Hannah, is 15. Spectacular. Then we're going to get minus 9i. I'm going to not skip out steps, you can. Good, minus 10i. And minus 2 times minus 3 is plus 6i squared. Okay. And at the bottom, in the denominator, we're going to have 5 times, these are exactly the same, except the signs are different. So I'm just going to times the first and the last, because the middles will cancel out. And I'm going to get 25 minus 9i squared. As I said, if you're comfortable skipping out steps, you're more than welcome to. Okay, and your key idea now is that I squared is equal to negative 1. So if I replace I squared with negative 1, we're going to end up with, okay, z being equal to, well, let's add like terms first of all. Minus 9i minus 10i is minus 19i. And then I'm going to have plus 15. 15 plus 6 times negative 1, because I squared is negative 1. So it becomes effectively 15 minus 6. And 15 minus 6 is 9. So I get minus 19i. 15 minus 6 is 9. So I get minus 19i plus 9 in the numerator. And then the denominator, well, I squared is going to be negative 1. So it's going to become 25 minus 9 times minus 1, which is 25 plus 9, which is 34, right? So the question said, okay, go write it in the form a plus bi, which just simply means I've got to have a real part, and then I've got to have the imaginary part. So we're going to say z, the way we're going to write it is going to be, we're just going to split this up, okay? So we're going to say that's equal to minus 19i over 34 plus 9 over 34. that is now in the form z is equal to a plus bi. That's what we mean by that. Z is in the form a plus bi. So there is your answer to the first part of the question. Write it in the form z is equal to a plus bi. Okay. So the next part says, what is the real part of z? So that's z over there, that whole thing. Okay. So the real part of z is the real part of minus 99 over 34 plus 9 over 34, which is simply 9 over 34. So that is the real part of z. Okay. Then they ask for the imaginary part of z. And the imaginary part of z is just the coefficient of I. So the imaginary part of z, here's z over there, is going to be minus 19 over 34. And then Zonke, then they ask us for z star, which means what, Zonke? Yes, the conjugate of z. So that's the original z. Okay, what happens with the conjugate? The sign of the imaginary part changes. So instead of being minus 19i over 34, it's going to be positive 19i over 34. The real part stays the same. Okay, so that is the conjugate of z over there. Okay, hope that all makes sense. What's the key idea? Okay, when you're dividing one complex number by another complex number, what do? You multiply the top, the numerator and the denominator by the same thing. So you're timesing by 1. What do you times it by? The conjugate of the denominator. Okay, conjugate of the denominator. Right, there we go. That is page 1, all done. Right, page 2. Okay, in page 2, we're told given that is equal to 2 plus 3i over 2 minus I plus 5 over 2 plus I. Express z in the form a plus bi and hence state the real part of z, the imaginary part of z, and z star. Okay, it's going to become a bit of a lame question, but you'll see why now. But it's still nice. So, like we've always done before, tell me please, Kristen, how do you add fractions? That is indeed correct. You get a common denominator. So z is going to be equal to 2 minus I times 2 plus I. And then, Hannah, what do? Whatever we times the bottom by, we times the top by the same thing. So here I times the bottom by 2 plus I, so I must times the top by 2 plus I. So it'll become 2 plus 3i multiplied by 2 plus I. Okay, and over here, what did I times the bottom by? I times by 2 minus I, so I must times the numerator by 2 minus I. Nothing new there, same principles as algebra. Right, now we go simplify. And if I simplify, you're just going to use FOIL, and 2 times 2 is 4. Then I'm going to get plus 2i plus 6i plus 3i squared. Okay, and then distributing, you're going to have plus 10 minus 5i. And over here, you're going to have exactly the same except for the sign. So you just have to times the first and the last. So you're going to get 4 minus I squared. Okay. Right. Key idea, once again, is that I squared is equal to -1. Okay. So look out for your I squared. There's an I squared and there's an I squared. Okay. So we can think of that as being -1 and think of that as being -1. And if we neaten it up, we're going to get Z is equal to, well, let's do the constant terms. I'm going to have 4, and this is going to become 3 times -1 is -3, so it's going to become 4 minus 3, which is 1, and 1 plus 10, which is 11. 4 minus 3, 3 times -1, 4 minus 3 is 1, 1 plus 10 is 11, so I get 11 in the numerator there. Don't think I've left out anything. And then if we look at the imaginary part, you're going to have 2i, 8i, 8i minus 5i is 3i. So I'm going to get 11 plus 3i, okay, over 4 minus 1 is 4 plus 1, which is 5. So I get that all over 5. The question said write it in the form a plus bi. So we're simply going to say z is equal to 11 over 5 plus 3i over 5. And it's not lame, it actually worked out quite nicely. Okay, let's just check that again. 2 minus I times 2 plus I is 4 minus I squared, which is 4 minus minus 1, which is 5. 2 plus 3i times 2 plus I plus 5 times 2. It all looks good to me. If I made any errors, blame one of the 3 that's working with me. Okay, so there is your final answer to the question. Go write it in the form a plus bi. Then the next part of the question says they want us to determine the real part of z, bearing in mind that that's z over there. So the real part of z is simply going to be the part without an I in it, so it's going to be 11 over 5. And tell me please, Hannah, what's the imaginary part of z going to be? Good, well done. The imaginary part of z is going to be equal to the coefficient of I, which is 3 over 5. And Zonke, you seem to be becoming the conjugate specialist. What is the conjugate of z? Okay, well, gets right. You change the sign. 11 over 5 minus 3i over 5. The sign of the imaginary part of the complex number changes. Okay, right. That is page 2 done. Get in there. Alrighty. Page 3. Okay. Example 3. It says given x is equal to 3 plus I, y is equal to 2i minus 7, and z is equal to 3 minus 2i. Okay, evaluate in the form a plus bi. Z times x plus y, 2x times the conjugate of y, the imaginary part of x, y over z, and the real part of I to the 75 over the conjugate of z. Okay, so first of all, z times x plus y. So I've got z times x plus y. Okay, and that's going to be equal to, well, what is z? 3 minus 2i. Z is 3 minus 2i times x plus y is 3 plus I is x plus y, which is 2. We don't really have to worry about the bracket because it's a plus in front. You can put it in if you want to. It's going to make no difference. Plus 2i minus 7. So z is 3 minus 2i. X plus y is 3 plus I times plus 2i minus 7. Right, let's sort out the right-hand bracket. So what are you going to get? Kristen, you're going to get, yeah, cool. No, you're wrong, I'm afraid. It's going to be minus 4 plus 3i. Okay, so you're going to get 3 minus 7 is minus 4 plus 3i. Then we're going to just use FOIL. So I get 3 times negative 4 is negative 12 plus 9i plus 8i minus 6i squared. Okay, and I'm going to have, bearing in mind I squared is negative 1. We're going to have, this is negative 1. So you can get minus 12 plus 6, and minus 12 plus 6 is minus 6. And 9i plus 8i is 17i. So we end up with z times x plus y is equal to minus 16 plus 17i. Well done, team. Righty, Zonke, number 2. We've got 2 multiplied by x times the conjugate of y. So 2x, it means 2 times 3 plus I. X is 3 plus I. Okay, times the conjugate of y. And the conjugate of y, Zonke, is what? Yep, be careful here, guys. You change the sign of the imaginary part. So it's going to be 2i is going to become minus 2i. So it's going to be minus 2i minus 7. That is the conjugate of y. Okay. Doesn't matter which order we do things in, but it's easier, I find, to times the brackets out first. So if I times the brackets out, okay, you're going to end up with 2 minus 6i minus 21 minus 2i squared minus 7i. Okay, so I end up with 2 multiplied by, well, minus 6i minus 7 more i's is minus 13i, and then I squared is negative 1, so it becomes minus 21 plus 2, because I squared is negative 1, and minus 21 plus 2 is minus 19. And if we times distribute the 2, we get negative 26i plus 38. As I say, if you spot any deliberate errors, please let me know. ASAP. Minus 26i plus 38. Anyone who spots an error, you get a chocolate. Okay, virtual chocolate straight away. Right, let's try number 3. Okay, this looks like it could be quite juicy. Okay, so in question 3, we've got the imaginary part of xy over, we want to find the imaginary part of xy over z. So now that becomes an instruction. So I want the imaginary part of, well, xy is 3 plus, x is 3 plus I, so it's 3 plus I, y is 2i minus 7, that's xy, over z is 3 minus 2i. Right, let's neaten up the top. So I'm looking for the imaginary part of 6i, okay, minus 21 plus 2i squared, okay, 6i, sorry, minus 21 plus 2i squared minus 7i all over 3 minus 2i, which, Hannah, is going to become what? Well, it's going to be the imaginary part, and we're going to have 6i minus 7i is negative I, okay, and then minus 21, I squared is minus 1, so it's going to be minus 21 minus 2, which is minus 23, so I get minus I minus 23 over 3 minus 2i. Okay, right, I think I'm going to have to turn over the page here. So I've got the imaginary part of minus I minus 23 over 3 minus 2i. Okay, just get that down. The imaginary part of minus I minus 23 minus I minus 23 all over 3 minus 2i. Okay. Right, all over 3 minus 2i. The imaginary part of minus I minus 23 over 3 minus 2i. Okay, and, well, how do I do that division? To do that division of a complex number, you're going to have minus I minus 23 over 3 minus 2i. And Kristen, what are times the top and the bottom by? Good, the conjugate of the denominator. Okay, so you times it by 3 plus 2i, 3 plus 2i. Whew, the sum's getting long. Right, so now I'm going to get the imaginary part of if I times the top out, I get minus 3i minus 2i squared. Just be careful of careless errors. Okay, minus 2i squared. Minus 23 times 3 is going to be 69. Okay, so minus 69. Okay, and then minus 23 times 2 is minus 46i. Okay, minus 3i, minus 2i squared, minus 69, minus 46i, all over 9 minus 2i squared. Okay. And if we go neaten it up, I'm looking for the imaginary part of minus 3i minus 46i is minus 49i. Minus 2i squared is minus 2 times minus 1, which is 2. 2 minus 69 is minus 67. All over 2 minus 2 times I squared is plus 2 all over 11. So the imaginary part of minus 49I minus 67 over 11 is simply going to be equal to, now I can drop that notation, minus 49, because now I've answered the question. So your final answer is minus 49 over 11. That is quite a long sum, and that is the solution to what is the imaginary part of xy over z. Okay, so this is equal to the imaginary part of xy over z. Lovely stuff, the trilogy behind me. Okay, top of your game, top of your game. Right, now nearly done. Last question is go find the real part of I to the 75 over the conjugate of x, okay, and x is equal to 3 plus I. Okay, right, so I want the real part of I to the 75 over the conjugate of z with x being equal to 3 plus I. So I'm looking for the real part. Well, how do I deal with something like this? Well, I always, if it's an odd exponent, I always write it as I times I to the 74. That gives us I to the 75. The conjugate of x, well, if x is 3 plus I, then the conjugate of x is 3 minus I. So I'm looking for the real part of I times, well, this will be I squared. 2 times what gives me 74? 2 times 37, okay? And we're just going to keep that at 3 minus I for now. So I'm left with the real part of I squared is negative 1, okay? So this is going to be negative 1. And then negative 1 to the 37, negative 1 to an odd exponent is still going to be negative 1. So I've got I times negative 1, which is negative I over 3 minus I. Alrighty. Now, I've got the real part of minus I over 3 minus I. Okay, to work this out, you're going to have to times by, good, Zonke, the conjugate of the denominator. So I'm going to times the conjugate of the denominator is going to be 3 plus I. And I've got to times by 3 plus I over there. Okay. And I end up with, okay, the real part of minus, okay, if I times this back out, I get minus 3I minus I squared. And at the bottom, I get 9 minus I squared, which gives, I'm looking for the real part of negative 3I. I squared is minus 1. Minus 1 is plus 1. So negative 3I plus 1. Okay. All over 9 minus I squared is 9 minus minus 1, which is 10. Okay. Good day, brother. So I get the real part of minus 3I plus 1 over 10, which in other words is the real part of minus 3I over 10 plus 1 over 10. Okay, and the real part then is going to simply be equal to 1 over 10. Whew, I thought that was quite an innocent sum. It turned out not to be. So the real part of I to the 75 over x star conjugate of x is equal to 1 over 10. As I said, if you made any deliberate errors, okay, please let me know ASAP. Righty then. Okay, your homework is to complete exercise 3, page 5, all of C and all of D. Good times. Thank you once again. And let's say goodbye to our special guests. Farewell to Zonke. Bye. And to Kristen. Farewell. And to Hannah. Goodbye. Okay. See you all when we see you. Arrivederci.